Hey guys, what's up? In this video we are talking about the areas of simple shapes. Actually we have different types of shapes. Sometimes we have simple shapes and sometimes we have complex shapes. And the calculation of area is easier, okay, in simple shapes, but if we have complex shapes, so we have to break down the complex shapes into simple shapes to calculate the area. And why in simple shapes? Because we have the formulas to calculate the area of simple shapes. You can see here we have rectangle, triangle, trapezium, parallelogram, again a triangle. So these are simple shapes because we have the formula to calculate the area of this one, okay, of these shapes. Clear? But sometimes if we have complex shapes, so we have to we have to separate the complex shapes, we have to divide the complex shapes into simple shapes so that we have simple shapes and we can apply their formulas to calculate it. So let's start. Here you can see here we have this rectangle. How? Because here you can see we have 90 degrees on each side of this rectangle, so this is a rectangle because we have 90 degrees. And what's the area? Okay, let me draw it again. Here you can see here we have a rectangle. Area means all the space inside the boundary, okay, all the space inside the boundary is called area. You can see this space inside this boundary, okay, this whole space is called the area of this figure. So we have to calculate the area of this rectangle. Okay, I have taught you in the previous videos about the areas and formulas of all of these, okay, and also the definition of it. Now we're just applying the formulas to calculate it. Let me write the formula of this rectangle, of the area of this rectangle. Here area is equal to length multiplied by breadth, okay, length multiplied by breadth. So what is the length of this rectangle and what is the breadth of this rectangle? Here usually we take length which is greater one, okay, which is the greater side. We take this one as a length usually, okay, but you can take any one of the length, or we can say any one of the side as a length and any one of the side as a breadth. Okay, so here okay, if I take this one as a breadth and this part as a length, so area will be equal to length multiplied by breadth. It means that here if 5 is the length and if 2 is the breadth, so I'm going to multiply 5 by 2. Here I will get 10. 5 multiplied by 2 is equal to 10. Okay, now 10 what? The units are in centimeters. You can see here we have length in centimeters, okay, but we know what is area. Area is actually, okay, wait a minute, okay, we have calculated the area. It is actually, you can see here we are going to multiply this length and this breadth, let's say, okay, this is also in centimeters and this is also in centimeters, so we have 2 times centimeters. Or in other words, what I can say here, I can say let me write it again. I can say that here actually 5 centimeter, it is going to multiply, 5 centimeter is going to multiply with 2 centimeter, okay, so 5 2s are 10 and centimeter multiplied by centimeter, it means that here we have 2 times centimeter, okay, 2 times centimeter, so centimeter multiplied by centimeter will be equal to the square of this centimeter. Okay, so you can also say that here areas, okay, area will be equal to the square of its unit. Okay, we have to multiply the constant terms which is 5 and 2, and also we have to multiply the units, or we can say that here if we are not multiplying the units, we can say that here the unit okay, it will be equal to the square of the unit which are used here. Clear? It means that here, let's say if we have here 5 meters and 2 meters, it means that here we have 10 meters square. The area is 10 meters square. Let's say here we have millimeters, 5 millimeters and 2 millimeters. So here we have 10 millimeters square. Clear? So here we have centimeters and centimeters. So I can say we have 10 centimeter square. We always have to write the unit in a square form because area is always in a square. Clear? So that's the area of this rectangle, of the first rectangle. This is the area, okay, this is the formula of the area of a rectangle. And it is actually the same as for a square, okay. Actually here square has all sides, okay, all sides same. Square has same sides, so I can write here, because here let me draw it. Let's say this is a square, so if this one is the length and this one is the breadth, okay, so area will be the same. Length is going to multiply with breadth, but here, because both of them are same, in a square we know that all the sides are same, okay. I have told you this in the previous videos. In a square all the sides are same, so here length is equal to this breadth, so I can write length instead of this breadth because both are same, all the sides are same. So for a square I can write here length, okay, length multiplied by length, or I can write, because bases are same, I can write it as a square of length, okay. I can say that in a square we can use this formula, or we can use length multiplied by breadth, okay. It will give us the same answer, but usually we use this one, square of the side length of one side, okay, square of the length of one side. Clear? Actually I have told all of these in the previous videos. Clear? So that's why I am going it, okay, I am giving you an overview of it. Clear? Okay, so that's our first part. Now let's see our second part. Here we have a triangle, okay. This one is a base, you can see, okay, this one is a base, and here we have a 90 degree. I have forgotten to draw it, okay. Here we have a 90 degrees. Okay, first of all let's see what's the formula of this of the area of a triangle. The formula is 1/2 base multiplied by height, okay, base multiplied by height. So here 1/2 is a constant, we know. And what's base? Base is actually this one, this 7 centimeter is the base, this 7 centimeter is the base. Clear? So I can write 7 instead of this base. And now what's the height? Okay, I have told you that height is actually the perpendicular distance from the top corner to this base. From the top corner to this base is actually our height, okay. Let's say if this one, okay, if this side is given to us, let's say it is 10 centimeter, okay. Let's say this side is 10 centimeter, and let's say this side, okay, this side is 4 centimeter, let's say 4 centimeter, okay. So from both of them neither is the height, because it is actually not a perpendicular distance. Perpendicular means here we should have a 90 degrees, okay. If I draw a straight line from the top corner to this base here, if we get a 90 degree, if our line lies on 90 degrees with respect to this base, okay, so in this case is the height. In this case, this length, this distance from the top corner to this base, this distance will be our height. Otherwise, if the angle is not 90, so it's not our height. So we have to check that which is our height, okay. So actually height is this one, 3 centimeters. So base is going to multiply by height, like this one, okay. Here 7 centimeter base and 3 centimeters height. So 7 3s are 21 over 2, clear, which is equal to 10.5 centimeters. Okay, actually not centimeters, we have a square of centimeters, clear. Here we have 10.5 centimeters square, clear. So that's the area of this triangle. Okay, this is the formula and this is the area of this triangle, clear. 1 over 2 base multiplied by height. Now let's see our next figure, which is a trapezium. Okay, now let's see the formula of the area of this trapezium. Here we know the formula of the area of a trapezium. It is 1 over 2 sum of parallel sides multiplied by height. Okay, so here we have 1 over 2, here we have sum of parallel sides. P1 is the first parallel side, P2 is the second parallel side, and it is going to multiply by the height of this trapezium. Here you can see here, this one is our first parallel side, this one is our second parallel side, and here what is the height? Okay, you can see here we have here we are given with this length. Okay, the length of this side is 5 centimeter. Okay, but it is not actually the height, because here it is not present at the 90 degrees. Okay, here this one, okay, you can see this height. Okay, this one, it is present with 90 degrees. So actually this is our height. Okay, because we will only get the height if we have the length. Okay, or we can say if we have the perpendicular distance. It means that here we have 90 degrees. Okay, here the distance, or we can say the line, is present 90 degrees with the other line. So in this case we will get our height. So our height is 4 centimeters. Okay, let me write it. Here we have 1 over 2 first parallel side. Okay, you can consider anyone as a first parallel side. Let's say this one, 7 is our first parallel side, plus P2, let's say 9 is our second parallel side, and here we have the height, which is, you can see, 4 centimeters. Okay, so here this 2 is cancelled by this 4. Here I will get 2. 9 plus 7, okay, or we can say 7 plus 9, it will be equal to 16. Okay, and this 2 in the multiplication, here we have 16 2s are 32. Okay, 32 what? 32 centimeter square. Okay, because here we have centimeters, so I will write here square of centimeter, because area is always present in square. Clear? So this is the area of this trapezium. Okay, I hope you're getting my point. Now let's see this triangle. We have this one. First of all, you can see this is our base. Okay, from here to here, from here to here, this one is our base, which is of 1 centimeters. Actually the formula of the triangle is same, which is equal to 1 over 2 base into height, and base is actually this 1 centimeter. So I can put the value of base in it. It is 1 centimeter, and here we are going to write the height. Okay, height is the same. It means that here height should be the perpendicular distance. It means that we will get the height if there is a 90 degree present. Okay, if there is 90 degree present here, so in this case this is our height. Okay, you can see here we have 90 degrees here. Okay, let's say if this length, okay, this length is given to us, let's say, okay, so it will be not our height because it is not present at a right angle. Okay, right angle means 90 degree. So height will be equal to the length from the top corner to this base at 90 degrees. Okay, so actually our height is actually 5 centimeters. Okay, this dotted line shows that here from here to here we have 5 degrees, and here we have 90 degrees with the extension of this base. Clear? So actually our height here is 5 centimeters, and here we have 5/2, or we can say it 2.5 what square centimeters. Clear? We have to write square with this centimeters. Okay, clear? Now let's see this one. Okay, this is a parallelogram. How? In a parallelogram, we know that opposite sides are equal. You can see opposite sides are equal and parallel. Okay, here you can see these two sides are parallel, these two sides are parallel, and they're also equal too. Okay, how? You can measure the length. Okay, both of them will be same. Clear? This is a parallelogram. Okay, formula is same. Okay, for the parallelogram, it means that here area, actually I have taught you all the formulas in the previous videos. Okay, so formula will be the same. It means that here it is equal to base multiplied by height. Okay, base multiplied by height. Okay, now what is the base here? Okay, you can consider anyone here as a base. Okay, but you have to consider here one as a base, because here we need height. Okay, it means that here we need a perpendicular distance if we are considering this one as a height. Okay, but you can see this. Okay, here perpendicular distance is given to us. Okay, you can see here perpendicular distance, we can say a perpendicular line is drawn with respect to this line and this line, because here both are parallel. So if 90 degrees is present here, so it is also present at 90 degrees here. It means that here, if we consider this one as a base, this 10 as a base, so we can consider this 3 as a height. Why? Because it is present at 90 degrees. Okay, so this line we can say is present at 90 degrees. Okay, from here to here. Okay, the length of this line from here to here, it is our height. Okay, from one parallel side to the other parallel side. Okay, this is the length. Okay, this length will be our height if it is present at 90 degrees. Clear? So if we take this one as a base, okay, so we need a perpendicular height here. So we are not taking this one as a base, because here the perpendicular height is not given to us. We will take this one as a base, because here the perpendicular distance, perpendicular height we can say, is given to us. Clear? So our base is 10. Okay, and our height is 3, so it is equal to 30 centimeters square. Okay, areas is always in squares. Clear? Okay, so one main point is that you have to take the perpendicular distance from one point to the other point. Okay, otherwise it will be not considered as a height. Clear? So I hope you are understanding my points and terms used in videos. So that's it for this video, calculation of areas of simple shapes.
Access the entire Mathematics Demystified course at learneasy.us.